Hello, good afternoon everybody. Myself is Manmohan Krishan, lecturer in chemistry, Government Polytechnic College, GTB. Today my topic is orbital concept of covalent bond. So before discussing about orbital concept of covalent bond, let's have a brief introduction of what is covalent bond. So what is chemical bond? So chemical bond is the force of attraction which holds the constituent atoms together is called chemical bond. So the bond is formed when two atoms come close to each other and there is a force of attraction between them. So chemical bond may be of different types. It may be ionic bond, covalent bond, coordinate bond, or and another types hydrogen bond and metallic bond. So today our topic is orbital concept of covalent bond. So as you know that ionic bond is formed between two ions, that is cation and anions, but covalent bond is formed when two atoms share electrons, mutually share electrons. So covalent bond is the bond formed by mutual sharing of electrons between the combining atoms is called covalent bond. So when electrons are shared between them, that is called covalent bond, and when electrons are transferred from one atom to another, that is ionic bond. So the mutual sharing of electrons between atoms, so there is a formation of a covalent bond. So examples of covalent bond: formation of for example formation of hydrogen. Hydrogen atom has one electron only. In formation of hydrogen H2, two atoms of hydrogen contribute one electron each for sharing and occurring the configuration of helium. So configuration, electron configuration of hydrogen is 1s1. The two electrons from hydrogen are shared between them and there is a formation of a covalent bond. So the picture is shown in which one electron from one hydrogen and another electron from second hydrogen, they are shared between them and there is a formation of a covalent bond. So in this picture the electrons are shared between them, but in the ionic bond the electrons, one atom transfer electron to another electron atom. So in covalent bond the electrons are shared between them. So this is example of a hydrogen molecule. So another example of oxygen molecule. So here the configuration of oxygen, as you know, the atomic number of oxygen is 8 and the configuration of oxygen is 1s2, 2s2, 2p4, and the valence shell of oxygen has 6 electrons, 2 electrons are in ground state and 6 electrons are in valence shell. So out of these 6 electrons, 4 electrons are in pairing form, that these are called lone pair of electrons. The electron configuration of oxygen is outer electron configuration of oxygen is 2s2, 2p4, and the picture above shown is 2 electrons at one oxygen are unpaired. So they combine with each other, form double bond. So below the picture shown, in ground state there are 2 electrons in the inner shell, and at valence shell there are 6 electrons. So the electrons are shared, 4 electrons are shared between 2 oxygen atom and there is a formation of oxygen molecule. So this is another example of a covalent bond. So first example was hydrogen molecule, another example was is oxygen molecule. Next is hydrogen fluoride molecule. So here one hydrogen combined with fluorine atom. So one electron from hydrogen is shared between is shared with fluorine, another electron of fluorine, and the formation of hydrogen fluoride. So, both the electrons are shared between them and the formation of a covalent molecule. Another examples of covalent bond are chlorine chlorine, in which one electron is shared, and hydrogen fluoride, water molecule, ammonia, and methane. So, in methane there are 4 covalent bonds, CH4. In ammonia, NH3, there are 3 covalent bonds, and in water there are 2 covalent bonds with hydrogen atom. General characteristics of covalent compounds. The first of all is non-polar nature. These compounds do not form ions and thus are non-ionic in nature. So, as ionic compounds are polar, so polar compounds are those compounds in which there are poles, means there are negative and positive charge or at the 2 poles of ionic compounds. So, when there is a negative and positive charge, that compound we call polar compound, and when there is no charge in the compound, there is no charge separation in the compounds, that is there is no positive and there is no negative charge, this is called non-polar compounds. So, ionic compounds do not have charge, so there is no charge separation, as most of the ionic covalent compounds are from homonuclear atoms, and these are non-polar nature. So, covalent compounds are non-polar nature, so they do not form ions. Low melting and boiling points, they are mostly liquids and gases at room temperature. So, due to weak intermolecular forces, these have low melting and boiling points. So, as ionic compounds have weak strong forces, and they are interconnected with each other in crystalline structure, but in covalent compounds they are weak intermolecular forces between them. So, maybe van der Waals forces. So, they have low melting and boiling points. So, when in contrast to ionic compounds which have high melting and boiling point. So, covalent compounds have low melting and boiling points. Electric conductivity, they do not conduct electricity in the fused or in solution state. Ionic compound conduct electricity in fused or in solution state, because there is mobility of ions, but here in covalent compounds there is no mobility of ions, there is no mobility of charges. So, they do not conduct electricity. Solubility, soluble in organic solvents and slightly soluble in water. So, as polar are soluble in polar solvents and non-polar are soluble in non-polar solvents. So, organic covalent compounds are non-polar. So, they are soluble in non-polar solvents, that is organic solvents. So, but these are slightly soluble in water. The bond is rigid and directional and thus give rise to space isomerism. In ionic compound the bond is not rigid directional, but in covalent compound the bond is rigid and directional and give rise to space isomerism, and there is a characteristic shape for the compound. The compounds undergo molecular reactions which are incomplete and usually complex. So, organic compounds show simple ionic compounds show simple ionic reactions, but in organic compound covalent compounds the compounds undergo molecular reactions, so which are incomplete and usually complex. So, there are 2 types of theories to explain covalent bonding. These are electronic theory of covalency or Lewis concept, and another is orbital concept. So, Lewis concept or electronic theory of covalency. According to this theory, covalent bond is the force of attraction which arises due to mutual sharing of electrons between the 2 atoms. This type of bond is found between 2 similar non-metallic elements or dissimilar atoms. So, according to Lewis concept, covalent bond is found due to force of attraction which arises due to mutual sharing of electrons between the two atoms. So, when there is a mutual sharing of electron between two atoms, so there is a force of attraction. So, this force of attraction is due to the formation of octet. This leads to formation of octet. As we have already discussed about oxygen molecule and hydrogen molecule. So, there is a formation of octet, that is 8 electron in the outer configuration, in the outer shell. So, in oxygen molecule there are 6 electron in one oxygen. So, it requires 2 more electron which it shares from another oxygen atom, and so the mutual sharing of electron is due to formation of octet. So, covalent bond are formed due to force of attraction which arise due to mutual sharing of electron between the two atoms. So, this type of bond is found between two similar non-metallic elements or two dissimilar atoms. That is, it may be from homonuclear elements, for example, hydrogen, hydrogen, oxygen, oxygen, nitrogen, nitrogen, or to dissimilar atoms. The examples already discussed is hydrogen fluoride, HCl. Both the atoms A or B are short of one or more electrons than the next noble gas configuration. So, as both the atoms forming covalent bonds, they are short of one or more electrons than the next noble gas configuration. For example, hydrogen has 1 electron short of from helium, that is noble gas, and oxygen has 2 electrons short of noble gas, that is neon. Fluorine has 1 electron short of next noble gas, that is neon. So, if both the atoms share 1 or more electron, the shared pair become their common property. As a result, both the atoms occur noble gas configuration. So, after sharing, both the elements occur noble gas configuration. For example, two hydrogen molecule, when they share electrons, they get noble gas configuration. So, after sharing electrons, so and oxygen, when they share electrons between them, so they occur noble gas configuration. If both the atoms share 1, 2 or 3 electron each, single bond, single, double or triple covalent bond is formed respectively. For example, the single bond example is hydrogen molecule, double bond example is oxygen molecule, and triple bond is formed in nitrogen molecule. The number of electrons contributed by an atom or sharing to form a covalent bond is called covalency. So, how many electrons are shared between them, that is called covalency. If they share 1 electron contributed by each, so the covalency is 1. And if they share 2 electrons, so the covalency is 2. One shared pair of electrons, single bond, the example is hydrogen molecule. 2 shared pair of electron, double bond, the hydrogen oxygen molecule. 3 shared pair of electrons, nitrogen, the example is nitrogen triple bond. So, there is a triple bond between 2 nitrogen atoms. Generally, bond distances decreases as we move from single through double to triple bond. That is, if there is single bond, the bond length will be more, and if there is a double bond, so the bond length will decrease, and if there is a triple bond, there is a further decrease of bond length. Limitation of Lewis-Langmuir concept. So, this concept failed to explain how the atoms are held together in the molecule like hydrogen, chlorine, etc., in which there is no ions and hence there is no electrostatic force of attraction. As in hydrogen or chlorine molecule, so there are no ions, so there is no attraction, that is electrostatic force of attraction. So, and how they are held together. So, the shape of molecule containing covalent bond. So, it does not tell about the shape of molecule which has covalent bond. The release of energy during the formation of covalent bond. So, how much energy is released or how much energy is absorbed during breaking of bond, this concept does not tell about that. So, there are two theories to explain these limitations. These are valence bond theory or orbital concept and molecular orbital theory. So, these theory explain the why homonuclear atoms are homonuclear molecules are formed and what is their shape. So, orbital concept of covalent bond, valence bond theory of covalent bond. This theory was put forward by Hitler and London in 1927 and further developed by Pauling and others. According to this approach, a covalent bond is formed by the partial overlap of two half-filled atomic orbitals containing electrons with opposite spins. So, this theory was put forward by Hitler and London in 1927 and developed by Pauling and others. So, according to this theory, covalent bond is formed by partial overlap of two half-filled atomic orbital. So, as already discussed about the Lewis concept, so according to that concept, the bond is formed by the covalent bond is formed by mutual sharing of electrons between the two atoms. But in this orbital concept of covalent bond, the bond is formed by the mutual partial overlap of two half-filled orbitals containing electron. That is, there is a overlap of half-filled orbitals. So, let us remind about orbital. So, what is orbital? And orbital is a space around nucleus in which there is probability of finding the electron is maximum. So, orbital is a space around nucleus where the probability of finding the electron is maximum. So, the covalent bond is formed by overlapping of two half-filled atomic orbitals containing electrons with opposite spins. That is, two orbitals that having opposite spin, they overlap with each other and form covalent bond. Formation of hydrogen molecule on the basis of this concept. Hydrogen atom has only one electron which is present in the 1s orbital. The nucleus of each hydrogen atom attract the electron cloud of the other hydrogen atom. In this way, two hydrogen atoms start approaching each other. So, the picture shows two hydrogen atoms. So, the spheres are shown as 1s orbital is spherical symmetrical. So, one electron in of hydrogen is in 1s orbital. So, 1s orbital one electron from 1s orbital of one hydrogen overlap with when they approach each other. So, overlap with another hydrogen atom that has 1s electron, 1s electron. Okay. So, there is a formation of a hydrogen bond between two molecules, two atoms. So, formation of a covalent bond between two atoms of hydrogen. So, at first the hydrogen molecule was shown by sharing electrons, but here the hydrogen molecule is shown by orbital concept. A stage comes when the electron clouds of hydrogen atom partially merge with each other or overlap. This overlapping results in the release of some energy and the formation of strong covalent bond between two hydrogen atoms as shown above. So, when the electron cloud of hydrogen atom partially merge with each other or overlap, this overlapping results in the release of some energy and the formation of a strong covalent bond between two hydrogen atoms. Formation of hydrogen fluoride molecule on the basis of this concept. So, where the 1s electron from hydrogen, a 1s orbital of hydrogen having one electron overlap with p or electron of F fluorine atom. So, the configuration of fluorine is, outer configuration of fluorine is 2s2 2p5. So, in which there is single electron, fluorine has unpaired single electron overlap with. So, the electron is in p orbital. So, the p orbital of fluorine overlap with 1s orbital of hydrogen. So, this is a formation of a covalent bond. So, partial overlap part of electron cloud of each of two half-filled atomic orbital becomes common. So, partial overlapping means when one orbital overlap in other partially overlap. There is no fully overlapping, there is partially overlapping. So, part of common electron cloud of each of two half-filled atomic orbital becomes common. The strength of the bond depends upon the extent of overlapping, that is, more the overlapping, more will be the strength, greater the overlapping, stronger is the bond. Also, according to Pauli's exclusion principle, that an orbital cannot have more than 2 electrons, must have opposite spin in order to minimize the force of repulsion. So, atomic orbitals, so two atomic orbitals at the time of overlap will have opposite spins. So, the overlapping orbitals must have half-filled orbitals with opposite spins. So, more will be the overlapping, more will be the strength of bond. Types of overlapping and the nature of covalent bonds. So, strength of bond is determined by the extent of overlapping. Larger the overlapping means stronger the bond, more energy is released when bond is formed and more energy is needed to break the bond. So, extent of overlapping is determined by the nature of atomic orbitals, the way in which they overlap each other. So, covalent bond is strong if the overlapping is more. So, overlapping depends upon the nature of atomic orbital, that is s orbital overlap at larger extent and pp orbital as compared to pp orbital, the way in which they overlap each other, that is they are overlapping at internuclear axis or they are overlapping sideways. So, according to that the strength of bonds vary. Types of overlapping and nature of covalent bonds. So, depending upon these factors, covalent bonds are classified into two types. These are sigma bonds and pi bond. So, overlapping, according to overlapping, these are called sigma and pi bond. So, sigma bond is that bond when two half-filled atomic orbitals overlap at internuclear axis, the bond formed is called sigma bond. So, when two half-filled atomic orbital, that is both have one electron, so with opposite spin, so they overlap with each other at internuclear axis. So, that axis, that line that joins the two nucleus. So, when they overlap at each other at that line, so the bond formed is called sigma bond. So, the sigma bond is formed by one of the following types of the overlapping: SS overlapping. So, when s orbitals overlap each other, so the mutual overlapping of half-filled s orbital of two atoms always leads to the formation of sigma bond. So, when s orbital of one atom overlap with s orbital of another atom, so there is formation of SS overlapping and formation of sigma bond. The examples are hydrogen molecule. So, there is a formation of a sigma bond. So, these are types of covalent bonds, sigma and pi bond. sp overlapping, the bond formed by overlapping of half-filled s orbital of one atom and p orbital of another atom is again a sigma bond. For example, hydrogen fluoride molecule. Here s orbital of one atom overlap with p orbital of another atom. So, this is sp overlapping, that is s orbital of one atom and p orbital of another atom, they overlap with each other and there is a formation of sigma bond. So, here the overlapping is again at internuclear axis, that is that line that joins to nucleus. So, when there is overlapping at that line, so this is called sigma bond. PP overlapping. When the partially filled p orbitals of two atoms get close enough to overlap each other along the internuclear axis, the bond established in this way is sigma bond. For example, fluorine molecule. So, when two p orbital overlap each other at internuclear axis, so again sigma bond is formed. So, when two p orbital overlapping each other, that is fluorine molecule is formed here. So, the overlapping is again shown at internuclear axis, that is that axis that joins to nucleus. So, where the fluorine atoms are written, you can assume them that as a nucleus. So, the line joining that is internuclear axis. So, when there is overlapping is at internuclear axis, that is called sigma bond. So, we have done SS overlapping, SP overlapping and PP overlapping. So, SS overlapping, SP overlapping and PP overlapping. Okay. So, there is formation of sigma bond. So, due to the maximum overlapping taking place in the formation of sigma bond, these bonds are quite strong. The single bond present in all molecules are always sigma bond. So, when there is a sigma bond, when there is single bond, that means that is a sigma bond. So, another bond is pi bond. So, when half filled p orbitals overlap sideways, little overlapping, the bond formed is called pi bond. The electrons participating in the formation of pi bond are called pi electrons. As both the lobes of the p orbitals are involved in the sideways overlap, the same pi bond is formed above and below the internuclear axis. So, pi bond is formed when there is sideways overlapping. So, when the orbitals overlap sideways, so above and below the internuclear axis, so there is a formation of a pi bond. So, pi bond is shown here. Pi bond is formed between two atoms which are already linked to each other by sigma bond. So, pi bond is formed only in the presence of sigma bond. Here sigma bond is shown in between them. So, pi bond is formed, example you can say example of oxygen. Okay. So, pi bond just a minute. So, pi bond is shown here. So, there is formation of pi bond, planar molecule, each carbon is triangular planar with pi clouds above and below the plane. So, comparison of relative strength of sigma and pi bond. So, strength of covalent bond depends upon the extent of overlapping. Greater the overlapping, more is the energy released and strong is the bond formed. So, covalent bond strength of covalent bond depends upon the extent of overlapping. More will be the overlapping, more will be the strength, and more energy is released and stronger is the bond. So, pi bond is formed by sideways overlapping. So, as there is overlapping is less, so the strength is also less. So, since the axial overlapping is greater as compared to sidewise, a sigma bond is stronger in comparison to a pi bond. The relative strength of three types of sigma bond is SS, SP and PP. Since axial overlapping of is greater as compared to sideways, the sigma bond is stronger as compared to pi bond. The relative strength of three types of sigma bond is SS, there is more overlapping in SS orbital. So, the strength of sigma bond in SS is greater as compared to SP and PP orbital overlapping. Next is concept of hybridization. Generally, the covalent bond is formed by an atom equal to number of unpaired electron in it, but the atoms of beryllium, boron and carbon are an exception to this generalization. For example, the covalent bond of hydrogen is formed when there is equal sharing of a number of electrons. Okay. So, and there is a sharing of unpaired electrons, but in beryllium, boron and carbon. So, in beryllium the configuration of beryllium is 2s2